Once we understand the bonding and structure of metals, then we can know what kind of properties they'll have, and therefore we can decide what kind of uses they'll have. So I'm going to list some of the properties that all metals tend to have, and for a few of them we can explain why it's going to have those properties. The first one is metals tend to be malleable. Malleable just means flexible or bendy. If we go to our structure that all metals have, where they've got these positive cations in rows and columns with delocalized electrons between, you can see the reason that it will be malleable is because we've got these rows. And because these rows are all made up of positive cations, if one of these was to move, it would repel and make the next one move, which would make the next one move. And that means that the whole row can move at the same time. So this structure of rows made of positive cations means that whole rows move, which means the whole thing can change shape. So it's malleable because rows can move. Okay, next structure that all metals tend to have is they have high melting points. And that means they also have high boiling points. Because they've got those high melting points, at room temperature, they tend to be solid, all of them except mercury. And that's because of what we need to do to get them to melt. Because we've got this structure where all the ions are close together, it's a solid at room temperature, and in order to get this to melt, we'd need to get these positive cations to be able to move apart from each other and flow over each other. In other words, we'd need to break the bonding. We'd need to break the attraction between the positive metal cations and the delocalized electrons. Because this is a strong attraction, a strong bond, it would take a lot of energy for us to break it. So it'd take a lot of heat energy for us to make this metal melt. So the reason they have high melting points is because the attraction or the bonding is very strong. Okay, last of the properties that I'll explain is all metals will conduct electricity. Some better than others. Copper and silver are very good conductors of electricity, but all of them to a certain extent. And that is very simply because of these delocalized electrons. That's the most simple one about in terms of conducting electricity. For something to conduct electricity, it just needs a charged particle that's able to move around. These electrons very obviously are charged, they've got a negative charge, and because they're delocalized, they're able to move through the structure of the metal. So I'm just going to write conducts electricity because of the delocalized electrons. Okay, so if I had an exam question that said, does rhodium have a high or a low melting point, and explain why? Even though I've not heard of that before, if I looked at my periodic table, I would see rhodium, that is a metal because it's on the left-hand side. That must mean that it's got a high melting point because of the strong attraction between the positive metal cations and the delocalized electrons. So that's why we can use a periodic table to work out the properties that something's going to have. I'll just go through a couple of other properties of metals. I won't explain these ones, but they're useful words to know. Metals are ductile. Ductile means that we can draw them out and make wires out of them. Metals tend to be sonorous. That means that if you had to hit them with something, it would make quite a loud ringing sound. They tend to be lustrous. That is a posh word for shiny. They tend to be good thermal conductors. That means heat passes through them easily, which means that if it was a very hot day and the sun had been shining on something metal, it would feel very hot when you touch it. Or if it's a very cold day, metal feels very cold if you sat on a metal bench because the heat travels through the metal very quickly. They're strong. A slightly better way of saying that is they have a high tensile strength. And not all of them but some are magnetic. And the ones that are magnetic are all next to each other on the periodic table. Feco, Ni, iron, cobalt, nickel. Those ones are magnetic. Okay, lastly then, now that we know these properties, we can get some uses out of them. You would all be able to think about loads of things you know that are made of metal and be able to say why they're made of metal. But if we just took these different properties in turn, ductile, we know that we make wires, electric wires, out of metal. And we can do that because they're ductile, we can draw them into wires, and because they conduct electricity. Sonorous, we make bells out of metal and other musical instruments. Lustrous, jewellery. The more lustrous, the more shiny a metal, the better it is for making jewellery with. Thermal conductors. A saucepan. A saucepan works because it lets the heat from the bottom of the saucepan go through the metal and get into the food that's inside the saucepan. High tensile strength, things like bridges. In fact, sometimes they're useful for making other materials out of. So if we had concrete, it wouldn't be very strong. But if you put metal rods through it, something called reinforced concrete, it makes it really strong because of that high tensile strength of the metal. And magnetic, we can make electromagnets, which are useful for various reasons, out of metals that contain iron, cobalt or nickel. So there you go, that's the properties. That is why they have those properties for these three, explaining it using our structure of a metal. And that is how we know what kind of uses metals have.